Assalamualaikum and hi everyone. So in this session, I will explain to you the focus part. Firstly, what you need to know is within the anode disc. This is the anode disc. There are two compositions. Firstly, target, and another one is the base. So this is the target. The purple color is the target. It is the area where the electron coming from the filament bombarded or accelerated into the target area. The other one is the base. This is the base. Base is made of molybdenum and the target is made of tungsten. Okay. And on the target, we have the focus part where we are going to explain in detail in this session. So the focus part, the meaning of the focus part is the area on anode which is bombarded by electron coming from this filament. Okay, so this focus part will determine the amount of X-ray fall or produce. So the larger the focus part, there is greater amount of X-ray is produced. And thirdly, the focus part will determine the image resolution. So there are two image resolution from the focus part, small focus part and large focus part. Small focus part will produce better resolution or high resolution, whereby for large focus part, it will produce poor resolution. Okay, this small focus part is coming from small filament size, and large focus part is coming from large filament size. So bear in mind, in the cathode, they are composed of two filament size, small size, and another one is large size. So small filament is coming from, small focus spot is coming from small filament size, and large focus spot is from large filament size. Okay, so for small focus spot, it will cause high heat generated. Due to why? Because small area on the anode. So look at here, this is small focus spot size compared to here large focus spot size. So the anode, the electron that been bombarded from the filament is confined onto small area. That is why the heat generated is large, comparable to large focus spot. The electron that coming from the filament confined towards large area, so that the heat generated is lowered compared to small focus spot. Next, the exposure. So the exposure for small focus spot, it only allowed small exposure, whereby for large focus spot, we can allow large exposure. Why? Because this is small focus spot, small area. If we allow large exposure, the large exposure meaning we are using high milliampere. What happened here? Milliampere is related to amount of electron that been bombarded onto the anode. So if we choose large exposure or large milliampere, meaning large amount of electron will be bombarded onto this small area. So the cause that is high heat generated, that will end up anode will be cracked. So, if we have large focus spot size, we can allow larger exposure, meaning we can use high MA value. So, much more greater amount of electron can be supplied towards the anode, comparable to here. So, let me take example. For low exposure, perhaps we can use up to 50 milliamps, whereby for this one, it can go up to 500 milliamp. This is just example, okay? This is not a true value, just for you to get a brief idea, okay? So, let's take a look at this diagram. I'm going to compare between these two diagrams. Let's say this is the filament electron. So the filament is small filament, small size filament, bombarded the electron towards the anode, and then we are going to have small focus spot size. Small focus spot size at the anode target. And this is the X-ray generated. This is electron. So the size of electron that fall onto the detector will be small. Compared to here, we are using large size of filament, greater number of electron produced, and then greater number of X-ray is produced. And the size of X-ray produced onto the detector also large. Next, I will explain to you how we get this kind of resolution. Small focus spot and large focus spot. Small focus spot, high resolution. Large focus spot, low resolution.